Hello, class. And this video, we're going to talk about section 4.6, which was the Poisson distribution. Let's start with an example of a Poisson experiment. So let's suppose after collecting some data, you know on average that you catch 8 fish every hour. If you are now interested in a 15-minute interval, well, how can we figure out what's the average number of fish you would catch in that 15-minute interval? Before we answer, we're going to do a little bit of setup like we always do with random variables. So we're going to let capital X be our random variable, and it's going to be equal to the number of fish we catch in 15 minutes. This random variable could take on any discrete value from 0 up to um, theoretically any number, but I think you can figure there will be some maximum number of fish you could catch in 15 minutes. And as you might expect, if we catch on average 8 fish every hour, then we would catch 8 divided by 4 fish every quarter hour. So that's about 2 fish every quarter hour. This situation that we've described here is what is described as is a Poisson experiment. So, what are some characteristics of a Poisson experiment? Well, for one thing, you can always tell if it's a Poisson experiment if you're given an expected or an average number of events happening in a fixed amount of time. That's really always the setup for a Poisson experiment. So, for example, let's say you know that a bakery averages 8 fresh baked loaves per hour, or an electronics store returns 10 items per day. So, it's a fixed number of events happening in a fixed amount of time. Let's talk about some notation for the Poisson experiment. We use capital P for Poisson, and we write X is distributed P of mu. And sometimes they use lambda in here as well. You can see both Greek letters, but really the parameter mu is what we're talking about, and that's going to be your mean or expected value. The standard deviation for this experiment is going to be the square root of mu. So let's do an example. An email user gets on average of 147 emails every day. So that's my mu value. It's an average value, and my time period is a day. Let X be the number of email a user receives per day. We know X is going to be a discrete random variable with a Poisson distribution. So we write X is distributed Poisson with my mean value in there, 147. We're going to use Desmos to help answer values about specific probabilities. So let's go ahead and go to Desmos. You can find this file in the MyOpenMath link as well, right below this lecture video. All right, I'm just going to pull this right on top of here. So this is the example we're going to do. An email user gets on average 147 emails per day. So X is the number of emails and is distributed Poisson 147 with my average. What is the probability a user gets exactly 160 emails in a day? So we're going to have Desmos help us answer this by doing first Poisson distribution. And you just type in Poisson dist, just like this. I don't think I'm supposed to use a capital letter. Oops. And you just enter the mean, which is 147. And you can see the cumulative distribution function with the mean right here at 147. And we're going to go ahead and find cumulative probability. So those are actually discrete. Let me unclick that for a second. You can see all the discrete values. They're actually individual values of each one that could happen up to, and then the mean is the most likely one, and then goes on from there. So to find the cumulative one, the first question says, what is the probability a user gets exactly 160? So what we could do is we could actually just click around here until we got to 160, almost. There it is, and that's going to be our probability. So 160 has a probability of 0.01803. You can also, by clicking the cumulative box, just go 160 to 160. I think this is a little easier way to do it. So between 160 and 160 is 0.018. So that's going to be the answer here. So let's put that in, 0.018. Try another one. What is the probability that the user gets at most 160 emails per day? So at most 160 means 0, 1, 2, up to 160 being the max. So if I go here and I change that to 0, that is any number of emails between 0 and a maximum of 160. So the answer is 0.867 if I round to 3 decimal places. Figure what is the average number of emails? Well, we already figured that out, right? They told us it's 147, so that's going to be the answer for this one. Oops, I didn't mean to do that. I did it again. Can I not click on this? There we go. 147. And what is the standard deviation of the number of emails? Well, that's going to be equal to the square root of 147. I'm just going to use this calculator right now, and that's 12.12. All right, so that's how you use Desmos to answer questions about the Poisson distribution. And again, remember that, oops, I didn't quite get to that slide. We say X is distributed Poisson, and you sometimes see lambda, sometimes you see mu. The mean of the Poisson distribution is just that parameter that you're given, the average number of things per hour or per day or whatever. And the standard deviation is given as the square root of that mean value.